Hello. In this lesson I'm going to talk about natural logarithm. This natural logarithm is a function that represents the inverse of the exponential function e at power x. However, before I start talking about this natural logarithm, let's take a look at the logarithmic function and its properties. A function of this form, y or f of x, that is equal to log in base b of x, where b, the base, is a positive number different than 1, and x, the independent variable, it's a positive number, is called a logarithmic function. Now if we look on this graph, these two curves represent logarithmic functions. The blue curve represents a logarithmic function that is decreasing, while the red one, it's also a logarithmic function, but it's increasing. The parameter that makes the logarithmic function to behave in such way is the base. So if the base b is greater than 1, the function is going to be increasing. If the base b is less than 1, but as we have the condition has to be positive, so it's somewhere between 0 and 1, then the logarithmic function is going to be decreasing. As you can see, they all go through the point 1 and 0. As a connection with the exponential functions, you can see how the domain for these logarithmic functions is limited to only positive numbers, while the exponential functions, as you remember, have a range which only takes positive values. We know this logarithmic function is the inverse of the exponential function, therefore I'm going to write that connection between the two as follows. If y equals to logarithm in base b of x, then x is going to be equal to b at power y. You may encounter it depending on whichever it's your independent variable, written in the following form as well. So if x equals to log in base b of y, then y is equal to b at power x. For the natural logarithm, the base is e, that e number that we just learned about in the previous lesson. The notation for the natural logarithm is ln x. We can read this ln x in short, or just natural logarithm, and it's equal to nothing else than a logarithm in base e of x. We try to simplify the notations, and instead of writing this log in base e, it's a lot easier to just say ln of x. That's basically all it is about natural logarithm. What I'd like to remind you, beside what I already talked about, is a few properties of the logarithm that are important for everyone to remember, because they're going to come in very handy when solving problems in this chapter. We know that the log x is actually a logarithm in base 10. If you don't see any base, that means it's a logarithm in base 10. A couple of particular situations. Logarithm in base b of 1 is going to be 0, regardless what the base b is, because basically any number at power 0 is going to give me 1. Logarithm in base b of b is 1, because again any number at power 1 is going to be the number itself, in other words. A very useful formula is the formula that allows us to change the base of a logarithm, because we don't always have the logarithm in the base that we want to work with. Therefore we need to be able to change it. So if we have a logarithm in base b of x, we can change that base, let's say to a base a, using the following formula. We're going to have logarithm in base a of x over logarithm in base a of b, the old base. This is a very important formula to know. As we know, logarithm in base b of a product, x times y, is going to be the sum of the logarithm in base b of x plus logarithm in base b of y. And the logarithm in base b of a quotient x over y is going to be logarithm in base b of x minus logarithm in base b of y. So it's a difference. And if we have the logarithm of a power, so logarithm in base b of x at power n, is going to be equal to n logarithm base b of x. That power comes in front of the logarithm as a multiple. And this is something that you need to know. A couple more identities that you're going to encounter all the time, at least in this chapter. Ln of e at power x obviously is going to be equal to x, and e at power ln x is going to be x as well. And with this, we conclude this lesson. Thanks for watching.